Hello everyone, welcome back to our YouTube channel Zero Touch Cyber. In this video we will dive into the address resolution protocol. Ever wondered how your computer sends data to another device on your network, like your printer or another PC? It all boils down to a little protocol called Address Resolution Protocol. ARP is a fundamental protocol used in computer networks. It plays a crucial role in communication between devices within a local network. Without ARP, devices on a network would not be able to efficiently communicate with each other using IP-based protocols. ARP, or Address Resolution Protocol, works at the OSI model's layer 2 to find the MAC address of a device on the same network segment using its IP address. It does this by broadcasting ARP requests locally and awaits a response from the device with the matching IP. Why ARP is necessary? MAC address discovery. ARP enables devices to determine the MAC addresses of other devices on the network, crucial for data link layer communication. Efficient data transmission. By obtaining the MAC address corresponding to a known IP address, ARP optimizes data transmission, eliminating the need for unnecessary broadcasts. Layer 3 to Layer 2 address resolution. ARP bridges the gap between network layer 3 and data link layer 2, addresses, ensuring seamless end-to-end communication. IP addresses are unique identifiers assigned to devices at the network layer 3, of the OSI model. They facilitate device identification and packet routing across networks, represented in IPv4 as 4 octets or in IPv6 as hexadecimal digits. MAC addresses serve as unique identifiers for network interface controllers at the data link layer 2 of the OSI model. They enable communication within the same physical network segment and are typically hard-coded into NICs by manufacturers, represented as 48-bit or 64-bit hexadecimal numbers. ARP packets contain the following fields. Hardware type specifies the type of network hardware being used, e.g., Ethernet. Protocol type indicates the protocol being used, e.g., IPv4. Hardware address length specifies the length of hardware addresses, e.g., MAC address length. Protocol address length indicates the length of protocol addresses, e.g., IPv4 address length. Operation indicates whether it's an ARP request or reply. Sender hardware address, MAC address of the sender. Sender protocol address, IP address of the sender. Target hardware address, MAC address of the target, only an ARP request. Target protocol address, IP address of the target. ARP request process. When a device requires the MAC address of another device on the same network, it broadcasts an ARP request containing its own MAC and IP addresses, seeking the MAC address associated with the target IP address. Only the device with the matching IP address responds to fulfill the request. ARP reply process. The device with the matching IP address responds with an ARP reply containing the requested MAC address. The original requester updates its ARP cache with the received MAC address. ARP cache, ARP table, and its importance. Devices store IP to MAC mappings in an ARP cache or table after receiving ARP replies. The cache minimizes ARP requests for frequently accessed devices, enhancing network efficiency. Device needs MAC address. When a device knows the target's IP address but not its MAC address, it requires the MAC address to communicate at the data link layer. ARP request. This request includes the sender's MAC and IP addresses and the target IP address. Response from target. The device with the matching IP address responds with an ARP reply packet, providing its MAC address. Updating ARP cache. Upon receiving the ARP reply, the requester updates its ARP cache with the IP to MAC mapping. After getting MAC address, device can communicate efficiently with other device.
If we ping 10.00.2 source IP 10.00.1, destination IP equal to 10.00.2, source MAC equal to A, Destination MAC equal to unknown. ARP table of computer A. Once computer A will receive ARP reply, it will update their ARP table. Now computer A has all information which required for basic communication, like IP address and MAC address. Now, computer A will encapsulate ICMP request packet into frame at layer 2. Types of ARP are proxy ARP, gratuitous ARP, reverse ARP, inverse ARP. Proxy ARP is a technique by which a proxy device on a given network answers the ARP request for an IP address that is not on that network. The proxy is aware of the location of the traffic's destination and offers its own MAC address as the destination. Gratuitous ARP is almost like an administrative procedure carried out as a way for a host on a network to simply announce or update its IP to MAC address. Gratuitous ARP is not prompted by an ARP request to translate an IP address to a MAC address. Reverse ARP, RARP. Host machines that do not know their own IP address can use the Reverse Address Resolution Protocol, RARP, for discovery. Inverse ARP, IARP. Whereas ARP uses an IP address to find a MAC address, IARP uses a MAC address to find an IP address. Key differences and complementary roles. IP addresses are used for higher-level logical identification of devices across different networks, enabling global communication over the Internet. MAC addresses are used for lower-level physical identification within a local network, facilitating direct communication within the data link layer. IP addresses are used by routers to forward data packets between different networks, whereas MAC addresses are used by switches to forward data frames within the same local network. ARP spoofing involves an attacker sending fake ARP messages to associate their MAC address with the IP address of a legitimate device. By poisoning ARP caches on other devices, attackers redirect traffic. Enables malicious activities like eavesdropping, man-in-the-middle attacks. ARP poisoning, a form of ARP spoofing where forged ARP messages are sent to both the target device and the router, poisoning their ARP caches with incorrect MAC to IP mappings, allows interception, modification, or dropping of network traffic between the target device and the router. Differences in ARP operation between IPv4 and IPv6. Address format, IPv4. IPv4 addresses are 32 bits long and represented in dotted decimal notation. IPv6 addresses are 128 bits long and represented in hexadecimal notation. Address resolution process, IPv4. ARP requests are broadcasted to all devices on the local network segment, and responses are sent back directly to the requester. IPv6 NDP uses multicast addressing for neighbor solicitation messages, which are sent to a solicited node multicast address. Neighbor advertisement messages are unicast back to the sender. Advantages of ARP protocol are efficient data transmission, dynamic address resolution, reduced broadcast traffic, dynamic network topology support. Thanks for watching this video. Do not to hit the bell icon. Please like and subscribe. Follow for more updates.